Alrighty, so here we are with Chapter 9, Section 3. We're doing arithmetic sequences and series. And so arithmetic just means that we are talking about a linear progression, so adding something or subtracting something each time. So we need to find the indicated terms of an arithmetic sequence. So they may say, tell me what the fifth term is, and then find the sums of the arithmetic series. So they might say, take those 5 terms and add them or sum them. Okay. So first thing that we're going to talk about here is what I just mentioned, but an arithmetic sequence is the successive terms that differ by the same number. So we're going to call this D, the common difference, okay? But the idea is that D can't be 0 because you can't just say that it's growing if you haven't actually added or subtracted anything. And the fact that these are very much like linear equations or linear functions. So the successive terms are linear. The common difference is represented by the D, okay? And it's founded by subtracting the next term with the previous term. So basically we are just referencing that is the slope or the change or the rate of change. Recall that linear functions have a constant first difference. And of course, that's why we call this a common difference, because it's going to be constant when you subtract one term to the next. The terms of an arithmetic sequence follow that difference as well. Thus, you can think of an arithmetic sequence as a linear function, as we mentioned up here, with sequential high natural numbers as the domain, meaning 1, 2, 3, 4, 5. All right. So the first thing we're going to do here is identify if this is an arithmetic sequence or not. So if it is an arithmetic sequence, we're going to find the common first difference, which is D, and then the next term. So in this case, the 6th term. So we need to determine whether the sequence is arithmetic. So all we need to do is take this number and subtract that number. So we're going to do -4 minus -10. So that is the difference between these two pieces. Don't know why I wrote that right there like that. Okay. So again, this digit is coming from -4 minus -10. And so -4 plus 10 leaves us with a common difference of 6, meaning to get from this number to this number, we added 6. Over here, to get from this number to this number, again, you're just taking 2 minus -4, but 2 minus -4 is also 6. The difference between here, notice it also goes up by 6, and then this goes up by 6. So we have found a common difference, and the common difference is 6. And once we found the common difference, we're going to apply that common difference and find the next term. And the next term is adding a 6. So 14 plus 6 gives us 20. So we determined whether it could be arithmetic since it had the same first common difference. It is. Found the common first difference, which was 6, and then the next term. All right, now the next one we're determining whether this is a sequence that's arithmetic, and if so, we'll do what we did in the previous one. So we find this difference here by taking the second term and subtracting the first term. So -5 plus 2 leaves us with -3, meaning you're going down 3 each time. This next one says that we're going to take -11 minus -5. So that's going to be -11 plus 5, or a -6. This difference comes from -20 minus -11, so -20 plus 11, which is -9. This one here is -32 minus -20, which means -32 plus 20, which is -12. So notice that this is not the same value. Okay, Granted, there is a pattern there, but remember that we're not looking for a pattern, we're looking for the same value. And so this is not arithmetic. That should be an H. All right. So we can't find the common difference because there isn't one, and we could get the next term, but that's not going to help us with arithmetic. All right, so now we're going to go through and find a recursive rule, which we've talked about before, which talks about using the previous term to get the next term. So these were in our previous notes. I think my pen is running out of ink. Yes, it is. All right, so it uses the previous term to find your next terms. And so there's no jumping. Okay, so you cannot say, I just want the 10th term, because you're going to need to find the 9th and the 8th and all of the ones before that in order to get there. So on your formula sheet, this is going to be given to you, but the idea is that a sub 1 is some sort of number, so you're going to indicate the first term. And then after you indicate the first term, you're going to say that to get the next term, you're going to take the previous term, so n minus 1, and add that difference. So again, this terminology is the next term, and take your previous term, and this one just represents the first term value. All right. So then we go to our explicit rule from the recursive rule. And so our explicit rule does allow jumping. So you can jump to any term number. So this one, of course, is a little bit more hard to find, but of course it allows you to do a little bit more. So the nth term of a sub n of an arithmetic sequence is given by this formula, where we take our first term, a sub 1, and we're going to add the term number that we're trying to get, minus 1, times that common difference. So a sub 1 again is the first term, and d is the common difference. All right, so let's go ahead and use this. They want you to find the nth term of the given arithmetic sequence. In fact, find the 12th term of the arithmetic sequence. So again, the examples that we have are going to be a little bit more direct than the test, for instance. So on the test, I might say something like, what is the 72nd term? Because I don't want you to sit here and list off all 70 of them. I want you to actually find a formula. So we're going to find a formula, and then we're going to jump to the 12th term in this case. So to find a formula, we're going to be able to take a sub n, and that's going to be equal to our first term, which we have, plus the term number that we want to get to, minus 1, times the difference. So that means that I need to find a sub 1, so that's not so bad, it's 20. My n is the fact that I want to get 12 terms, and the d is what we need to find in the common difference. So 14 minus 20 means that we're going down 6 to get from 20 to 14. 8 minus 14 means that we're going down another 6 to get here, another 6, and then 2 to 4. Oh, that's supposed to be negative 4. Is negative 6. So, little typo in your notes. That's a really ugly negative. Okay. All right. So that means that if we're going to find the 12th term, we need our common difference, which is negative 6. And now we're going to plug all that into the original equation. So to get any term number, in this case, we're actually trying to get the 12th term number. All we do is take the first number, which is 20, and add n, which is 12 minus 1 times our d, which is negative 6. So order of operations says to do this piece first. So we will take 12 minus 1 and get 11. But then take 11 times negative 6. Oh, 20. And then we will subtract 66. And so our 12th term is negative 46. Now, of course, you could have actually done that by just following the pattern a few times, okay? But the idea is that you can jump to that 12th number or the 100th term with this formula. So that is our formula. All right, the next one, again, arithmetic sequence, and now they want you to find the 11th term rather than the 12th term of the last one. So we're going to write our formula again, that to find any term, we take the first term, as long as it's arithmetic, n minus 1 times our common difference. So our a sub 1 is 9.2. Our n is 11, and we need to find our d. And remember that the d is the common difference, so what's happening, adding or subtracting to get from one to the next. So we're going to do 9.15 minus 9.2 and realize that it's negative 0.05. Just double checking. Okay. So then the next piece definitely goes down by another 5 if you imagine this as 10, 15 to 10, and then to 5. So we're going to go down again, negative 0.05, and again, negative 0.05, which means that our common difference is negative 0.05, and so we can plug it all into the formula. So a sub n is a sub 1, which is 9.2, plus our n, which was 11, trying to find 11 terms, minus 1 times our d value of negative 0.05. Alrighty. Continuing on, to solve this, we're going to add 10 and then multiply by negative 0.05. And so we're going to have 9.2 plus a negative 0.5 if we multiply that by 10. And so we're going to get 9.15 as the 11th term. Oh, I should be able to do that a little bit differently because that is not the same. 9.2 minus 0.5 is actually 8. I was wondering why that was so high. 8.7. Oops, 9.2 minus. Decimals are really exciting. Anyway, 8.7 is our 11th term. Alrighty. So then we get to a few others, and now we want to find the missing terms, okay? And so we're going to kind of work backwards here. So what's going to happen is we're going to take the number 17 and we're going to add or subtract some common difference, another common difference, another common difference, and then finally a fourth common difference in order to get to negative 7. Even though there are 3 empty boxes, we are adding 4 of that common difference. So to set this up, we have 17 plus 4 common differences, and that's going to equal negative 7. So if we want to find out what that common difference is, we can go ahead and solve this algebraically. So we can subtract a 17 from both sides and get 4 times that common difference equals negative 24. Divide by 4. and get a common difference of -6. So that means that every single time you're subtracting 6. So subtracting 6 from 17 leaves you with 12. Sorry, 11. Subtracting 6 from that gets you to 5. Subtracting 6 from 5 gets you to -1. And then subtracting 6 again gets you to -7. So I just wanted you to find that it was 11, 5, and -1. All right, this next one is giving you that same idea, only now instead of empty boxes, they are giving you this empty set here between 8 and 14, and then they want you to find the 5th term. So they don't want you to fill in the 9th through 13th term. They want you to use what you have to then find the 5th term. So lots of things going on. We're going to start with finding out what the common difference is. So to get from 8 to 14, there's technically 6 pieces between that. But that means that we're going to add 7 common differences. So A8 plus 7 common differences is going to equal our 14th term. So 85 plus 7 common differences is going to make 157, which we can do what we did before and subtract 85. And get 72 and divide by 7 and get a common difference of 10.2857. All right, so I did that incorrectly because there are actually 6 differences between them. I went ahead and listed out a sub 8 plus a difference would be a sub 9 plus another difference is a sub 10 plus another one is a sub 11. And so you can see that there's 1, 2, 3, 4, 5, 6 differences and not 7, which is what I had originally decided. So there are 6 differences, which is going to make this a lot more of a nicer digit than 10.2. That seemed a little bit off. So when in doubt, make a nice list like I did. So 72 divided by 6 leaves us with 12. What a nice digit. Okay. So that means that to get from one number to the next, we're going to add 12 each time. And so there's a few ways that we can go about this. One of them is to write the formula and then plug in a 5. And the other one is to make a list. And right now I'm going to make a list because writing a formula requires that we use the first term, and we don't have the first term. We'd have to get to the 5th term to get to the first term, so we may as well just do it in a list. So what I'm going to do is make a list of the term. And then the value. And so I want the 5th term, but I'm going to need the 6th and the 7th and of course the 8th to get back to it. So the 8th term is 85. But then to get from the 7th term to the 8th term, I had to add 12. So if I have to add 12 to get from here to there, to get backwards, I need to subtract 12. So 85 minus 12 makes 73. 73 minus 12 makes 61. And then finally minus 12 again makes 49. So that means that your 5th term is 49. Okay. Could you have used guess and check rather than these nice organized lists? Sure. But of course, if I'm going to have you find the like 100th term or something, guessing and checking is really going to not work out so well. So you do want to find some patterns that work better. All right, this next one here wants you to find the 11th term, and they give you the second and the third terms. So that one's a little bit easier because now you're going to just find out the difference between these two and not have to find out a significant amount of them. So a sub 3 minus a sub 2 is going to get you your common difference. So negative 121 minus negative 133 is your common difference. So negative 121 plus 133 is 12. And 12 is our common difference. So that means that if we want to get to the 11th term, we could go ahead and add 12 a bunch of times, or we could subtract 12 and get to our a sub 1 and write a formula, which is what we're going to do. So basically, we've been told that a sub 2 is negative 133. A sub 3 is negative 121. And to get from one to the next, you add 12. But of course, to get backwards, we're going to need to subtract 12. So subtracting 12 to get backwards means that negative 133 minus 12 leaves you with negative 145. So if we want to jump to our formula, or to the 11th term, we can fill in our formula here. So we can fill in that to get any term number, we need our first term, which we have, plus this number of terms that we want times d. So we want the 11th term. Our a sub 1 is negative 145, and our common difference, we said, was 12. So we can plug it in here to jump to the 11th term without having to list them out. And so we will have negative 145 that we will add 11 minus 1 times 12. And so we're going to have 10 times 12 minus 120. And so we're going to end up with negative 265 for the 11th term. So again, you could have just taken the third term and added a 12 and added another 12. And continued on with that pattern. However, why am I getting such a very large number when it's supposed to get more positive? Oh, that's not negative. That's positive. Negative 145 plus 120 leaves you with 25, negative 25. That's much more like the number I'm looking for. All right. In case you're wondering, it is late at night and I should go to bed. Okay. So let's fill in this last bit here. So an arithmetic series is the indicated sum of the terms of an arithmetic sequence. So the formula that we're going to use is the number of terms that we need. That amount times the first term plus the last term that you're trying to find over 2. So again, n is the number of terms, a1 is the first term, and an is the nth term, or the last term of those sequence. All right. So we're going to find the sum of the arithmetic series, and so we might want to rewrite this formula. So again, the sum is n times a1 plus an over 2. All right, so looking at what we need here, we already know that n is 18. We also know that the first term is 13. But then we need to find the pattern so that we can jump to the 18th term. So we're going to put this aside and we're going to instead find the arithmetic sequence equation and then plug in an 18 so that we can plug it in over here and find the sum. Lots of fun. So to get from 13 to 2, we're either adding or subtracting something, and so we're subtracting 11. Double check if that works here, and it does. And here, yep. So if we are trying to find an arithmetic sequence formula, we're going to take our first term and add n minus 1 times our difference. So our n is supposed to be 18. Our a sub 1, we already mentioned, is 13. And our d, or our common difference, is negative 11. So plugging that in to find the 18th term, we would need to take 13 and add it to 18 minus 1 times negative 11. So 13 plus 17 times negative 11. Let's see if we can get our proper number this time. Is 13 minus 187 is negative 174. So definitely going to be a negative number because we're going down pretty fast there. And so the a sub 18 that we need is negative 174. So now we can plug all the pieces into the S, or the sum of this sequence. So we need 18 terms for n. A sub 1 is 13. A sub n of 18 in this case is 174. And all of that divided by 2. So that means the sum of the first 18 numbers, or you could add them, I guess, by hand, is 13 minus 174 divided by 2. So 13 minus 174 is negative 161. So we're going to take 18 times negative 80.5. And so times 18 leaves you with negative 1,449. So if you were going to go ahead and do that by hand, you'd end up adding a bunch of numbers that would equal 1,000-ish. So that is that. So again, of course, towards the end, these problems end up being a little bit more complex. You have to use what you already knew to find the sequence, and then use that to get your number to plug into the sum of your arithmetic series. Alrighty, so there we go.